In one cycle, a heat engine absorbs 500 joule from a high temperature reservoir and expels 300 joule to a low temperature reservoir. If the efficiencies of this engine is 60% of the efficiencies of a Carnot engine, what is the ratio of the low temperature to the high temperature in the Carnot engine? The engine absorbs 500 joule from a high temperature reservoir. We denote this 500 joule of the heat as the QH. H stands for hot. So QH equal to 500 joule. The engine expels 300 joule to a low temperature reservoir. So we denote this 300 joule as a QC, where the C stands for cold. It is also given in the questions that the efficiency of the engines that we consider is 60% of the efficiencies of a Carnot engines. Mathematically, it means that this eta that denotes the efficiencies of the engine is equal to 60% of the eta of Carnot. Eta Carnot means the efficiencies of the Carnot engine. The question asks us to find the ratio of the low temperature to the high temperature. Means that we want to find the Tc over the Th. Again, C stands for cold and the H stands for hot. So Tc over Th. We want to find this ratio. Since the value of the QH and the QC is given, so we can apply this formula to find the thermal efficiencies of the engine. By substituting the QC as a 300 joule and the QH as a 500 joule, we obtain that the efficiencies of the heat engine is equal to 0.400. And the question says that this efficiency is the 60% of the efficiencies of the Carnot engine. So we can write down these equations that reflects the relationship between the efficiencies of the heat engine and the efficiencies of the Carnot engine. Therefore, the efficiencies of the Carnot engine is equal to the efficiencies of this heat engine divided by 0.6 or 60%. But this eta, the efficiencies of the engines, is equal to 0.4. So we substitute the 0.4 here, divided by 0.6, you will get 2 over 3. This is the efficiencies of the Carnot engine. But the efficiencies of the Carnot engines, the formula is equal to 1 minus Tc over Th. And we want to find the ratios of the Tc over Th. Therefore, we change these second terms in the formula as the subject of the equations. Then we will have 1 minus efficiencies of the Carnot engine. So by taking the efficiencies of Carnot engine as a 2 or 3, we will have the ratio of the Tc to Th is equal to 1 over 3. What is the meanings of the result we obtain here? It means that when the ratios of the temperature between the reservoirs is set as a 1 over 3, then the Carnot engines, the efficiencies can achieve a 2 over 3 or 67%. And the efficiencies of the engines that take 60% of the efficiency of the Carnot engine can achieve 0.4 or 40%.